Let me introduce myself. I've been around forever, wrote a book on MySQL and JSON. And if you need a copy of these slides, I'll put them on speakerdeck.com/Stoker after this presentation. And I work for a company called Percona. We're the open source database experts. If you need help making your databases run and applications run better, please see us at percona.com. And this talk is about SQL window functions. This is kind of an esoteric thing that usually people playing with SQL kind of put off until they've had a year or two under their belt, because it's not exactly the easiest situation. Now, this man here is considered brilliant. This mathematical equation doesn't make a lot of sense to me, but for some reason it does to him. And I got to warn you, he never actually made a SQL query in his life, never did a window function. He's actually never had to watch an Instagram video either, so he's lucky there. So want to warn you up front, your brain may hurt during this presentation. This is something where you might want to get the video later and go back, or grab my slides and go back and work through the examples. So two types of functions you normally see when you're doing statistical work in SQL or structured query language. Aggregate functions, which are like average, count, minimum, maximum, that sort of stuff. You're probably used to that from most programming languages you've had in the past, and probably hopefully from spreadsheets if you have a spreadsheet background. Window functions are a little bit different, where analytics basically give you a single summary statistic. Window functions, or an analytic function, can give you a value for each row or groupings of rows. It gets rather confusing, and I hope these examples will make things a little bit clearer. Want to warn you, analytics, statistics, numbers, and your sanity don't always match or mix very well. Presenting numbers is often tough. This is a screen of numbers and words on it. It's very tough to present this type of subject. Got to warn you, it's as dry as saltines in the Sierra and in the desert, so be very careful. Learning the stuff to present numbers from structured query language is very tough. So if you get frustrated at first, give it some more practice. Build in some sanity checks so you can double check as you go along to make sure what you're doing is right. Now, aggregate functions are fairly straightforward. As you'll see in a minute, window functions are not straightforward. The syntax is odd. The partitioning can be hard. Functions inside the window functions are not exactly intuitive. You have to read the documentation. They differ from implementation to implementation. So something that works on SQL Server may not work in MySQL or Postgres the same way you expect. So this is something where you need lots of practice to really master. And I got to warn you, this is not a spreadsheet. There are things that spreadsheets can do that window functions can't, and vice versa. So if you have a spreadsheet background, this will take a little bit of getting used to. If you have a SQL background, it's still going to take a little bit of getting used to. Now, the main thing that's kind of weird is partitioning. The trick is you are usually working with a current row and a certain number of rows preceding or following. Or if you're using all the ones before, it's called unbounded preceding, and anything following till the end is called unbounded following. This makes a little more sense in a couple of minutes, but this is one of those concepts that you have to play with for a little bit before it starts trying to leak into your skull. So here's some test data. Came in with a bunch of car brands and models and some prices. And yes, I know Ferrari 250 GTOs don't cost under $1 million, but just for sake of argument, we're going to have these numbers out here. By the way, if you have questions, please raise them. I'd rather answer them when you have them and it's relevant, and not have you wait, and then where it's not relevant and you're not going to get the answer. Okay, let's look at an aggregate function. This is very simple. We're going to count the number of rows that we have. We're going to sum up the price of all the vehicles. We're going to round the price of all those vehicles, and we're going to get the max price. So we have 10 rows, so we have 10 records. The sum is 1,545,897. That divided by 10 happens to match this number. And the most expensive car in inventory is this one. So you basically use an aggregate function to generate information on a column or columns. So we have this column counted, this counted summed, this one averaged, and this one is the max. Hopefully that's straightforward. Now grouping helps out making this a little more easier to read. So in this example, we find out that we have 3 Fords. The sum of that is $138,400. The most expensive car is $53,400. And if you round out this by 3, you come up with this number. This is fairly straightforward. As you see, we have one Pontiac, 18,000. Round that off, for all the Pontiacs we have, that's 18,000. The maximum is 18,000. Here we have 2 Chevrolets, and you see the sum here, the average of those two, and the total price, or the maximum price. So group by can make this a little better presentation. Now, something you can do for folks who like alphabetical order is you can add an order by. So we have to order by one of the columns we we asked for in the select query. So we have these alphabetized, which makes it a little bit easier. Now it's very simple. Aggregate's giving us one value. What about differences within the groups? That's what window functions are all about. It's how you gather the data for analysis. So hopefully this is going to be better analysis. So what you want to do is when you're reading your SQL query, if you see the word over, that should tell you it's a window function. Now, in this case, we're going to go out there and ask the brand, the price, and the sum of all the prices from our table named data, and then we're going to order it by brand, which is what you saw earlier. But the new part here is over. And over without anything in the bracket tells the database instance to apply the calculation over the entire column, similar to an aggregate function. Now, here the sum is for all of the vehicles. So our total price for all 10 vehicles is $1,545,897. Now, you can have multiple overs and do different analysis on the columns. This one's fairly simple. We're using over all the columns in this case, where we're counting the ID fields in the table, and we're summing the price. This is eerily close to something we saw earlier. So here's 2 window functions with the 2 overs, counting everything in these 2 columns. Now, something you can do that makes readability a little bit better is you can have your function you want to use, which is sum over W, and then over here, we actually define the window W as, and once again, over the entire column. So this is a different way of writing what you've seen before. Now, the handy part of this, it doesn't improve readability. Now, the definition clause can get rather weird. Now here it's saying, okay, we're going to take a look at the brand, price, and sum from our table, but we want to look at the current row. So we're going to use rows, and we're going to start at the current row. So our first Ford has a price of $4,800, and we're going to, or $48,000, and we're going to sum that up. Next row, okay, we're going to use a row, and we're just going to look at the current row. Now, this is not a useful example, but the idea is that you document what you're doing. This is not handy, but it shows you that here we're looking at just the current row only. Now, remember earlier when I said unbounded? Well, here we're going to look at all this information, select the brand, price, and summer price, and we're going to just look at the row with the unbounded proceeding. So our first row is $48,000, and our sum is $48,000. Our second row, the price of the car, an Audi in this case, and the sum is $48,000 plus $54,000, which is $102,000, and so on and so forth. So we keep adding this to the figure over here. So by the time we get down here and we add the nearly $1 million, we get our total. Now, once again, I want to go back to this because it might make more sense. You have a pointer of the current row, and you specify how many rows preceding and how many following. And if you want all of them, you use unbounded, either for preceding or following. And let's take a look at this one. Now here we're going rows, unbounded, preceding. So our first vehicle comes up again, the Ford, $48,000. So we're going to calculate the window for this. We're going to take the current row plus the unbounded preceding. Well, there's no previous row here, so the total is 48,000. Next row, we come down, an Audi for 54,000, and we're going to add the $54,000 to the $48,000 to get 102. Third row is a Dodge from a 75K. We add that to the number above, and we get this number. So we're basically saying, okay, I want the information for the current row and the stuff that preceded it. That's what rows unbounded preceding means. As I mentioned, this isn't easy, so play with this and it'll get easier. Rows between unbounded preceding and current row. So $48,000, there's no preceding row, so it's 48,000. Once again, we add the unbounded preceding, which is the one from where we are to the top of the column, and the current row, and we get this figure. And if we add 74.99 to this figure, we get this number. Kind of obvious, huh? But like I say, the wording's a little weird and the syntax is a little weird, but it gets easier as you go along. Here's another one. Window W as rows between current row and unbounded following. So we're going to take our 48 grand and we're going to add up the rest of this column to get this figure. Now, the next column we come down to is our total minus these two numbers, or this number. I'm sorry. So this number here is this number here plus 48 grand equals 154,5897, and so on and so forth. So rows unbounded preceding and current row is the opposite of rows between current row and unbounded following. This is something you have to play with to get used to the terminology, and you have to think the way that syntax works, unfortunately. It's not the most intuitive thing. So let's take a look at rows between one preceding and the current row. So the current row is 48, okay, and one preceding. Well, there's no preceding, so it's just 48. So current row is 54,000, and we want to add that and the preceding row, so we get 102,000. Now, this is where you're going to have to pay a little bit more attention here. We're going to take our number, our price is 75,000 almost, and if we add that value and this value, the one preceding row, we get this value. And once again, if we add 37,000 and 74,999, we get 111,999. I made these numbers kind of odd and fidgety so you don't get comfortable with them, and you have to kind of look through this to get the gist of it. Okay, here's another one. We're going to look at a window W as rows between one preceding, so that's the one before our current row, and one following. So our current row is 48,000. There's no preceding row, so we add 48,000 and 54,000 to get 102. Now, when we go down the Audi, our preceding row is 48,000, and our following row is 74,999. So this number here is the aggregate of the Ford, the Audi, and the Dodge. Hopefully this is making some sense. Okay, get even wilder. Let's say we want to do rows two preceding and the current row. So first row, current row, 48,000. There's no two precedings, so our value just sums to $48,000. Audi, current row is 54. One preceding row is 48,000. Excuse me. Second preceding row, not there. So the value that we end up 102,000 is the 48 and the 54. Now the first row we went into that actually has the two preceding is this one, the Dodge, 74,999 plus 54,000 plus 48,000 is equal to 176,999. Now, something else you can do is you can put in order commands inside your window. This one is window W, order by brand. So you see that we have our various rows and they're ordered thusly. And what we're doing is we're summing by brand. Whoops, hold on. Audi is 54 plus 64. Oh, 24. So what we're doing is the Audi total brand sum is 54,000. Chevrolet, the brand sum is 241,499, which is the 64,999 and the 122,500. Dodge, we're summing 74,999 and 7,300. So, we also get the grand sum from above. Oh, I see what I'm doing. I'm sorry. This is basically saying unbounded proceeding. So 54 and 54, there's no proceeding. This we're adding the values of the two Chevys with the 54,000 from above. And here we're summing the Dodge plus the values of the Chevrolet and the Audi. Okay, you could order by range instead of just by rows. So we're going to order by brand. So this is sorted over here. And the range is the current row. So we're going to get a sum of all the Audis. So there's only one, so there's 54. If we want to sum the Chevrolets, this gives us the two Chevrolets summed, the two Dodges summed, the three Fords summed. Now, if you're not used to playing with SQL, it's very easy to do averages. The one thing I recommend that might be kind of hard to read is we're trying to average the price and we're rounding it to 2 digits. So you notice that the average comes out to 2 digits. If not, it gives a whole bunch of different information. As you want a proof of the math, 54,000 divided by 1 is 54,000. The 187,499 divided by 2 is the 93,749 figure. Now, something else you might want to take advantage is roll up. This gets kind of frustrating because it doesn't seem intuitive at first. We're going to sum all the brands. So our 10 rows, when we sum them up, is our 1,545,000 number. And what you don't see is here, this is our roll-up line, which says we've had 10 records, this is the sum, and this is the average. And this is actually a null hiding in here. It would be nice if it said roll-up or grand total or something like that. Unfortunately, SQL doesn't let us do that. Something else that's also interesting is the cube function. You group by cube, and if you notice, it's telling us that, like for Ferrari, there's one Ferrari, the model, and the number, and then it gives a grand total for Ferrari. We come down here for the Challenger. This is something you got to work with. This example doesn't work really well, but it's something else that you might play with to kind of break out your information. Percentages. This is kind of tricky if you're not used to SQL. We're going to use a window function to get the price and divide it by the total sum of all the prices, our 1,545,000 number, and we're going to multiply that. These two are going to run first, and we're going to multiply that by 100 and round it off to 2 places. So to prove the math, almost a million is 64.49% of our total grand value. If you like time series data, one thing you can do is order by price descending, rows between unbounded preceding and current row. So we're ordering by price, and our most expensive one is this 250 GTO, and the total sum is $999,999. If we add the price of the Corvette here, we end up with this number. If we add in the third most expensive car, we end up with this number. So that's between unbounded preceding and the current row. So we keep adding these here until we get this number. If you want to figure out the difference from average, we take the price, we take the average, which is the average of all 10 cars, divided by 10, and we can see the difference. Our GTO is $136,000 lower than the average price of the car. The Ferrari here and the Corvette kind of skew these numbers. Difference between one previous and current is kind of interesting. Also, I'm going to introduce the lead function. What we're going to do is we're going to select the brand, model, and price, and then the price of the one vehicle in front of what we have. So this is telling us that the first vehicle we have price is $18,000. There's no preceding line. Now, the difference between 18 and 37 is 19. The difference between 37 and 48 is 11,000. So this is a way to get differences in numbers. So if you're stack ranking customers or order numbers or prices, this is a way to do that sort of thing. Now, lead has a corresponding lag function, which if you want to get the next value in the stack off and compare that. So lead and lag take a little bit of playing with to get used to, but this is kind of a quick introduction. By the way, this stuff can get awfully complicated. Don't shoot yourself in the foot. In this example, we want to know how much more this car is than the lowest car. So our GTO is a mere $18,000, and the next car up is 106% of $18,000. So 37K is 106% of 18. 48,000 is 167% of 18,000. Now I'm going to update the data a little bit. We need some numbers that are the same to show off how some of the ranking works. Rank and stack rank take a little bit of playing with. We have our most expensive cars listed, Ferrari, Corvette, and all that. You know, it's 1, 2, and then we have 3 cars with the same price. Now, with a rank, you get 1, 2, 3, second 3, third 3, and the next value is going to be 6. In a dense rank, it's going to be 1, 2, 3, 3, 3, 4. So you can think of this as a time period or a some other way to segment your data. So be careful working with rank versus dense rank. So this is just the basic. It's kind of hard to cover a lot of this in 30 minutes, and this is not an easy subject. I applaud you for sitting through this much. Window functions out there, like you saw, dense rank and rank. There's row number, n-tiles, which you can do quartiles with the nth value. They're fairly simple to use. Just use the function name over your window definition. And in this case, we're just adding a simple row number. This comes in handy. Sometimes we don't want to rely on an identifier field. So let me do a quick wrap up and we'll get to questions. Window functions are useful, but you need practice. As you saw, the terminology can get kind of crazy. You have to sit down and double check what you're doing. And don't forget to use those aggregate functions. Sometimes people overcomplicate where they're going.